Now in this session we will take some problems based on mutual inductance. Take down the first one. If the mutual inductance between two coils is 0.2 Henry, calculate the EMF induced in one coil. Calculate the EMF induced in one coil when the current in the other coil is increased. Current in the other coil is increased at a uniform rate from 0.5 to 3 ampere in 0.05 seconds. If the mutual inductance between two coils is 0.2 Henry, calculate the EMF induced in one coil when the current in the other coil is increased at a uniform rate from 0.5 to 3 ampere in 0.05 seconds. Now first list out what are the given quantities. That makes us our calculation simpler, or we can approach it easily if we first list out the given quantities. Given the mutual inductance between two coils, that is M, 0.2 Henries. Calculate the EMF induced in one coil. So actually they are asking what is the EMF induced in one coil when the current in the other coil is changing, that is what is the mutually induced EMF. Now the rate of change of current in the other coil is, we may consider two coils. In one coil, let us say this current in this coil is I1. So I'll show you switch also to show that the current we can vary by switching on and off, and a galvanometer. Now di1 by dt, the rate of change of current is, so the current changes from 0.5 to 3 ampere. So we can calculate this as final current minus initial current. The change in current is 3 minus 0.5. Final current minus initial current divided by dt. So that is 0.05. How much are you getting? 3 minus 0.5 divided by 0.05. Yes, this is 50 ampere per second. We know the equation. The mutually induced EMF is given by M into di1 by dt. It's 0.2 into 50. So this comes to around 0.2 into 50 is 10 volts. 0.2 into 50 is 10 volt. So the mutually induced EMF is 10 volt. Now we'll take down another problem. Second one, that was very simple one. So now let's take another one. if an EMF of 5 volt is induced in a coil, if an EMF of 5 volts is induced in a coil, when current in an adjacent coil varies, when current in an adjacent coil varies at a rate of 80 ampere per second, what is the mutual inductance of the two coils? What is the mutual inductance between the two coils? If an EMF of 5 volt is induced in a coil, when current in an adjacent coil varies at a rate of 80 ampere per second, what is the mutual inductance between the two coils? So again here also first you list out the given quantities. Given an EMF of 5 volt is induced in a coil when the current in the adjacent coil varies at a rate, therefore it is mutually induced EMF, that is 5 volt, and the rate of change of current in the other coil you can take it as di1 by dt. So I will just draw the figure here through a switch. So this current may be I1 when the switch is closed. A galvanometer to detect the presence of current. The rate of change of current is 80 ampere per second. You need to calculate what is the mutual inductance between the coils. Now you know the equation EM is M into di1 by dt, or from this equation it gives like M is EM divided by di1 by dt. Now this is 80 divided by 5. M is not 80 by 5, I think it's 5 volt, and the rate of change of current is 80. So EM divided by di1 by dt, EM is 5 volt and di by dt is 80. So 5 by 80, and do the calculation, it will come around 0.0625 Henry. Or you can write it as 62.5 millihenry. So the mutual inductance between two coils is 62.5 millihenry. Mutual inductance between two coils 62.5 millihenry. In the next session we will do some more problems.